Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences ITB. So for today, we are going to talk about additional application of the derivative still, but we have a specific focus on the application that is on the global or absolute extrema, absolute maximum or minimum. So let's start. Previously, we have learned that how to find the local or relative extrema of a function. What about the extrema in an interval? How do I can find all the maximum and the minimum? The absolute maximum or minimum we usually call. So this is the definition. If f is a function on interval I that contains the number c, then the value fc is the absolute maximum of f on I if fx is less than or equal fc for all x in I. It means if we draw the graph of this in the Cartesian coordinate, this is the highest among all of the points in the interval. This is the highest among all the points in the interval. This is the highest among all the points in the interval. The highest among all the points in the interval. Okay, yeah, and we can do the same thing for the absolute minimum. There's the definition here. So the maximum can happen at the stationary point, at end point, at stationary point, at stationary point, and the minimum also. So in this first case, we have the maximum is in the stationary point, but the minimum is at end point. But in this one, the minimum and maximum is attained at the end point. What about this one? The maximum and minimum is attained at the local relative extrema. And this one, the maximum is attained at the stationary point, but the minimum attains at the endpoint. So this you have the variation of the possibility for the absolute extrema of a function. So if a function is continuous and on a closed bounded interval, that is a closed interval a, b, and the function will attain its absolute extrema, that maxima or minima. By the way, maxima or minima is the plural of maximum and minimum, either at end point of the interval, a or b, or at critical number c, such that c is between a and b. Okay, yeah? And remember again, what do we mean by critical points? So critical points are either a stationary point or a singular point. What is stationary point? That is c comma f prime c, such that f prime c equals 0. And what is singular points? That is c comma f c, such that f prime c doesn't exist. Okay, yeah? Let's look at the example. Determine the absolute extrema of this function on a given interval, this one, the closed bounded interval 0, 3. First of all, we have to find the stationary point. To do that, we have to find the first derivative, and the first derivative is given by this. We can factor out 3. We can factorize this, so the stationary point is given by x equals minus 3 and x equals 1. But x equals minus 3 is not included. Why? Because it is not in the domain. Of course, we could also look at the local extrema by using the first derivative test, looking at the monotonicity of the f prime, monotonicity of the f. But we don't have to do that because we are looking at the absolute extrema, okay, yeah, on a closed bounded interval. Absolute extrema on a closed bounded interval, we can just compare. The endpoints are x equals 0 and x equals 3, and there are no singular points. Okay, and then we can check that f0 is this, f1 is this, f3 is this, and the absolute minimum occurs at x equals 1 with the minimum value minus 1, and the absolute maximum occurs at x equals 3 with the maximum value 19. Okay, let's try another example. Find the absolute maximum and minimum of fx at this domain, minus 3, 0. First of all, the same. It can happen at stationary point, To find the stationary point, I have to find the first derivative. And 6 can be factored out, and you have this, and you can factorize this to have this. So the stationary point is given by -2 and 1 is not included because it's not in the domain. And the second one, the function doesn't have the singular point. Why? Because I have a polynomial. Polynomial doesn't have singular points. Endpoint is x equal -3 and x equals 0, and we can check all of these points. We have f minus 3 is 2, 13, and f0 is -7. So the maximum occurs at x minus 1 with the maximum value is 13, and the minimum value occurs at x equals 0 with the minimum value -7. Okay, so for this one, we have discussed about the application of the derivative, that is finding the absolute extrema on the closed and bounded interval. What about if I want to find the absolute extrema in an interval that is not closed or not bounded? We will talk about that in the coming video. Thank you.